Right. Let me also take the pdsa GitHub. So so we'll see the question here and try to and see the concept also.
Okay. Yeah.
Okay. So the first questioning deals with can you Uma, can you just read this question once? Then we'll go to that.
Yeah. Consider a pattern P of size m and text of size n. Both P and
Mhm.
T are strings containing digits in base 10. What does that
Hmm.
mean?
So base 2 means the digits will be 0 and 1. If it is base 8
They
means
have to
0
use
to
strings, no? Text only, no?
uh,
Why it is saying digits in base 10?
strings containing digits in base 10.
These are strings, right? And text
Yeah,
base.
Uma, still numbers can also be a string, right?
Okay.
I think so. Let's see.
Okay. To
Mhm.
implement Rabin-Karp algorithm for searching P, in P, we want to calculate the integer equivalent of a block T, I comma j plus m, say n into I. Is that so?
Uh,
Say ni using the integer equivalent of previous block T of I minus 1 is to I plus m minus 1, say n I minus 1. My God.
okay. So this seems like a little bit, confusing. Uh, so let's first see what Rabin-Karp algorithm is. Okay.
No, you are not this week, group.
Yeah, yeah. I mean, I'm just going up to
Go
push
to
it up.
home page, no? You can easily.
Yeah, it's here, right?
Okay.
Weekend. Rabin-Karp. Okay. So what is this Rabin-Karp algorithm first mainly used for?
For finding the pattern in the string, right?
Okay. Examples. So I can see only numbers here. Why not only numbers?
No, no, I don't think only numbers. Is it?
See
Okay.
that this is numbers, right?
Oh, okay. I thought the strings. Okay.
No. So see here we like this is the text, right? And you have the pattern here. So in
Yeah.
this long text of numbers, so you are trying to find 23, where and all 23 is present.
Oh.
So here is 2 3, here is 2
It
3,
is not
right?
meant for the alphabets, right? Only for the numbers then.
I think so.
Yeah. Okay.
Hi Shibin, hi Pooja.
Hi, Gopal.
Mm-hmm. Yeah. So coming back here, what about the? Okay, we are talking about week 11, so week 10 questions, and we are talking about Rabin Cop. So, so we can shall we take it like that? Rabin Cop is for finding the pattern for a numbers given number.
Yeah, as of now, yeah, you can take it. That's how the code also looks like, and it must be that.
Mm-hmm. And where you got any points on this?
Sorry, Gokul, I was away. I just came in.
Okay, okay. So okay, now Uma, shall we just explore this code quick? This seems to be a small code, right?
Yeah.
Okay, so we have the text and the pattern. Here we have the text and the pattern. Okay, number in the text and number in the pattern. They are initializing it to 0, right? And this is the position list which we are going to return at the end, wherever you have the pattern that is matched. Is that fine?
Yeah.
Okay. So what is happening in these lines? Length of pattern. So sorry, length of pattern is 2 here, right? This case.
Yeah.
Okay. So number in text equal to 10 into uh, num t. Isn't that, is that 0? Initially it's going to be 0. For the first iteration it's going to be 0
Yeah.
plus int of t of I.
The first digit we are
Okay.
converting to int, right?
Repeat.
The first digit we are converting to int. That means 2 in the text.
Correct. Okay.
Same thing we are doing for the pattern also.
Okay. So this thing is running for two iterations in this case, right, Uma?
Yeah, because I think we are going to check for the pattern length whether 23 is there or not, right?
Not sure though. Let's see.
Looks like that. It
Okay.
says 10 into MT. Okay, that's good.
So numpty is going to at this point it's going to store two.
Yeah.
Okay. At this point it's going to store
Hmm.
again two, right?
Yeah.
So during the second iteration, it's going to so what is the numpty already? So it is 2 into 10, which is 20, right? Plus the second
No,
number, which is,
for the second iteration you're talking about?
sorry.
Are you talking about the second iteration?
Yeah, I'm talking about second iteration,
Okay, yeah.
right? During the second iteration, we have numpty like 2 3, and in this case also it's 2 3,
Yeah.
right? Okay, good. So if numpty equal to numpty, which means the pattern is there at the right at the beginning itself. So you're going to add at 0. I mean, processed or append of 0 means the position. At the 0th position, you have a pattern match.
Yeah.
Uh, Guys, are you able to follow this? Others, Puja,
Yeah.
Shibin, Anwar? Okay.
Yes, yes, yes.
Oma, hope you are able to follow. You're also able to follow, right?
No, yeah.
Okay, great. And what do we have in here? So for I in range of 1, length of t minus length of t plus 1. Wow, what is this? Starting from 1, comma, what is length of t text? In this case, seems like 5, 10, 15. Okay, here we have 15.
Okay.
15 minus, what is length of t? It is 2 plus 1. So can you tell me what this is, Uma?
Yeah, I have to go through I actually we are going through the full text, right?
Yeah, yeah. So what's the
Okay.
value here? 1 comma 14,
Yeah.
right?
Yeah.
Okay, great. This seems like you're going to stop. You're gonna start at this point. I mean, first index, right? So you're starting at this point till the point. Here it is two numbers, right? So you just need to check it till the first. You got my point here. Why what how we are doing that? You don't
Yeah.
need to check the last digit. Last digit is not gonna match the pattern. So last digit equivalent to the length of the pattern, right?
Yeah.
So if it was 231 and you need to check until this point, you can stop at this point, right? You
Yeah.
don't need to go further towards the other indices. You follow what I'm saying,
Slightly. We
Uma?
want to check until the end point, no? Why we are
Yeah,
stopping?
we don't need to check it until the end point.
Okay. Starting index only. That's what you're telling.
Correct.
But if it is changes like 21, then we how will we know?
What do you mean by 21? Where,
For
Uma?
last number, if it is 21, it will not be matching, no? So we should check 2, 3, right?
Correct, Uma. So see, the point here is why we are stopping at you know length of t minus length of t plus 1. Do you understand why we are doing this?
Maybe is it that we check the one first two pattern, no? Maybe we are avoiding that. Is that so? See, already we have added the first two and we have added to the position list. So
So,
now we have
so
to do the rest,
hmm,
right? Is it?
correct. So first two means, so that's why you're avoiding, the
Yeah,
first index. So you're starting from 1.
yeah.
Okay. What does this ending iteration mean? I mean, length of t minus length of t plus 1. What does that mean?
Anyway, we will not have a pattern at the end starting, no? So that's why. Now
Correct.
yeah, got
Exactly.
it. Yeah.
You're right.
Okay.
Okay. So what's happening here again? So we have numpty, which was, earlier itself we saw 23, right? Numpty minus 23 minus int of what's happening here? of I minus 1. My suggestion would be, why don't we print numpty? Ravina, we are in week 10 here. So they are doing two changes, right? Come on.
Okay.
Both the things they are assigning it to numpty. So I just want to see what both mean. Okay. Okay. So so until this point we are okay, right? So during the first iteration, this value calculates to be 33.
So we're leaving the first two part because they've already added, right? So they are starting from, I think,
First
33.
index. I think they are starting from here now.
Yeah. Okay. Yeah. Yeah.
Okay. So then the after is going to be triple three. Okay. So this comes as triple three. If numpty, okay, this is because three digits, three we are doing. I think. Ah, see, now we have this is how it was earlier.
Yeah.
Which speed is this? First one or second one?
First three. Oh,
Okay, now this will give us a differentiation, right?
yeah.
Okay, so which means the index one.
Yeah. We're
Okay,
starting from 34.
correct.
Okay.
34. So how are they calculating the three? That is where the point is coming here.
Yeah.
So basically, they are taking this index, right? And then they are multiplying with the length of this, I believe. And they do the subtraction also. But shall we move ahead here, Uma?
Yeah. Yeah.
We don't need to go deep into this, right?
Yeah. Because we need only the theory part. That's fine. Yeah.
Yeah, only a theory of how it is happening. Okay, let me just submit this one. Okay, so these two are the correct options. But let's check it once again. Can do that currently. Okay. So to implement Rabincourt algorithm for searching P in T, we want to calculate the integer equivalent of the block from I to I plus M. So M is the size of the pattern.
Yeah.
Say Ni using the integer equivalent. Okay. So what I can feel here is I'll take my pen. Has anyone else done this question? Someone else want to take this question and explain this? Pooja, Anwar, anyone? Okay. So let us write it. Uh, Base pattern M is size of pattern. Okay. T is text and N is size of text. Right. So these much are given. We implement blah 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 for searching P in T. Calculate the integer equivalent of the block. In equivalent of text of I colon I plus m.
So what
Okay.
does this mean? Integer equivalent, what does this mean?
Um. So see, integer equivalent here in this case is, see here, Ravina. So here this is a string, right, Ravina?
Yes, sir.
Yeah. So it's a string, and that string you are trying to convert it to integer and find the value of the integer. You understand?
Like we have to count the number of characters in it.
So let's say x equal to 2, 3, 4, 5, 6, 7. I mean 6, 5. Okay, whatever it is. Okay. So this is a string, right? If computer is reading this, it will read it as a string. Okay. So if you do int of int of x, so this is what integer equivalent is. You got my point?
Yes, sir.
Okay. Fine. We are still trying to understand this question here.
No, we are completely converting that whole text to, sorry, yeah, string to integer. That's what we are doing in that step, right? We are completely converting this whole list of t. That's what happening, right?
List of the, yeah, Uma. This part you are seeing, right? You're talking about
Yeah,
this one.
yeah.
This is not a list, right? This is a substring.
No,
So
that
they're
whole
saying that
text we are converting, right? No,
how we are converting it out.
maybe what whenever we take two numbers, are we doing that in a block? That's what it's saying, right?
What do you mean? I'm still
No,
trying
we
to
are
understand.
converting that whole text to numbers, right? But
Correct?
in blocks
Yeah,
of the
we
length.
convert it in blocks only, right?
Yeah,
So first
two
we take
two.
33 and
Okay.
compare it with 23. Then 34 you compare it with something
Yeah,
like that. First you take these two. I mean, first two digits, then this two digits, then 43, then 32, then 23.
yeah,
Right? That's how we go. Okay. So they are saying that this block, this integer equivalent of this block is written as ni. Okay.
yeah,
Ni equal to uh, integer of t of I to I plus m, where m stands for the length of the pattern. Okay. So what will be the length of this, length of this text? Uma, can you tell? It is m.
yeah. Up to yeah,
So you are following this? Okay. Where are we? So, and equivalent of the previous block, this ni minus 1 um, equal to t of I minus 1 I plus m minus 1. So do we have a similarity here? What?
Sir, is it the just the previous element
Exactly.
starting from
You're
the
right.
previous?
Yeah, you're right. So let's say that we have numbers from 1, 2, 3, 4, 5. Okay, Uma?
yeah,
And we are trying to match pattern 34. Okay, so in this case, let's say we are at index, this index. Okay, for this index, ni will be 23, right? So and
yeah.
n minus 1 will be nm. I'm just
Well,
writing this m. Yeah, it's 1 2. Got the point? Little bit.
yeah.
Okay, so let's try to see this correct option first, then we'll go to the wrong option. So this is what is happening as of now. Okay, so we have text pattern. I is the, yeah. Someone want to say something?
No, sorry, I just yeah.
Okay. So text pattern index ni minus 1. Okay, we got the previous one also. These are all the inputs that we are giving to the calculate function. Okay. So let's take this example here. Okay. 1 2 3 4 5, and we are trying to find out 34. You got this? Got this question here?
Yeah,
Okay. So how do we find out? Um, so m equal to length of the pattern, which is equal to what? 2.
yeah,
Okay. So if we say that index is at this point, right? If index is 1, so and n minus 1 is going to be 1, 2. Are you guys following? Uma following?
Yeah.
Others? Ravina following? Pooja? Okay. Okay. So you have n minus 1 is 1, 2. So ni is nothing but you have this. So what this will give us is basically it will give the last element of this. Uma,
Oh, okay. Okay.
that's the point, whole point over here. The n minus 1 is what? 12 mod 10 times 2 minus 1, which is what? 1.
10 power, right? That is.
Sorry?
It is not 10 power.
Yeah, for 10 power only.
Okay.
Right? So what's gonna happen?
We get 2, yeah.
Right? So ni equal to 2 here. At this point, what is happening? So this 2 you are multiplying it with 10, right?
Adding
Plus,
the next integer, I think, right?
you are right.
T of I plus. What is I?
I is the current index.
Okay, 1. Okay. 1 plus 2 minus 1 will be give 2.
Correct. Which is 3.
No, sir, 3.
Yeah, got it. Yeah.
Very good. So we get the value as 23.
No, the T of is 2. Ravi, that's what I said, 2.
Yeah, T of 2, right? What is T of 2?
Is
Text
3.
of 2 is 3, no? So you get the point?
Yeah.
Okay. So seems like this is finding us with the text. But let's see why this option is wrong. Why the first option is wrong? Any doubt in this point? Any doubt in this option, Uma, Ravina,
No,
Pooja? Okay. So why is the first option wrong then? So seems like
Because it's M.
yeah, because it's m and it is supposed to be m minus 1. Uma, okay?
it should be 10 power 1, but that's giving 100, so it will be wrong, right?
Huh. So if you ask me how Gokul, how you answer such a question, I used to take an example and try to solve it like this. Sort of fast though.
Okay,
Okay.
but you are taking correct example. We all end up in a wrong.
It comes to that point also. But for this question, it's okay.
Yeah.
Yeah. Okay. So we are coming to the third option and fourth option. Okay, I'm building everything, but just putting here. Yeah, Uma. Someone else want to take this? Ravina, Pooja, Anwar?
So please take the same example.
Please take the what? Same example. Okay. And we are searching for 34. Yeah, Ravina, can you? And let's still be here only. Okay. I equals 1. Okay. And what? So in this place, it's 2. Ni equal to what? Can you tell me, Ravina? So for this question, what is ni minus 1? It is 12, right? Okay, I mean,
What is
understand?
the
Are you
I here?
understand?
1.
Sorry, Uma?
What is I here? 1. Okay.
1, 1. I is 1. Just take the
Okay.
same example, same thing, but in a different formula.
Okay.
Okay. So what is happening here? Uh, yeah, we have a ni equal to 12. I mean, sorry, ni minus 1 is 12 minus int of t of I minus 1. Okay. So
1.
int of seems like int of t of 0. Okay, let me do that. Int of what is t of 0? It's 1 multiplied by uh okay 10 power m minus 1, which is 1. So I think is it same, somewhat similar. What's the difference between that option and this option? Okay, here they are doing a modulo, and here we are doing, after multiplying we are subtracting them.
Okay. Yeah, you're right. The division here subtraction, right?
That's correct. Ravina, Ravina, can you tell me? Do you
Yes,
understand,
sir.
or you want me to
No,
explain
sir.
what similarity or difference between these two? No, right?
Um, yes, sir, please explain.
Okay, great. So let's say I'm giving you number 14532, and I want to find out what is the last digit of this number. Okay, how can we find out?
Mm, no, sir, please explain this line only, the black one which you have written, like T of 10, how it will count T of 10 as the list is not going to odd numbers.
Uma, can you tell me which point she is referring to?
You know what? And what is her question?
Ravina, what is your question here? Which
So,
box,
like
which black
what
box?
you have written in black pen, black handwriting, sir.
Oh, he
I
has
didn't
written the
know that.
final thing. What is happening in that line? It is int of t of I minus 1. I is 1 here. So that will become t of 0. T of 0 in this text is 1. So he is converting int. So it is 1 into what is happening. He is multiplying by 10 power 1. M is 2. 2 minus 1. So it is now we are getting 10. 12 minus 10 will give us 2.
So,
There we are doing 12 by 10, we got 2. Here we are doing 12 minus 10, we get 2.
12
okay,
mod
so
10.
we are subtracting 10 times, yeah.
Okay. So ideally, what we are trying to, this NA is nothing but, we are trying to find out the previous, what was that? The previous number's last digit, nothing else, right?
Yeah.
Okay. So should I continue explaining this, or shall we move further?
So we'll move to next question, sir.
Yeah.
Yeah, yeah. So this is also fine, I think, right? Nothing else is
Yeah.
here. Rest of the things also. So why is the last option wrong?
Because again, the same thing, no, 10 power m will give us only 100, it won't be correct.
Yeah.
One doubt, Gokul, have they given ni minus 1 as this kind of one digits?
Repeat what you told.
Have they given ni minus 1? Have they given properly that point alone? I'm not getting. Have they given us one previous digits? How do you come to that 1, 2?
Sorry, the I is the current question, right?
Yeah.
Mhm. So
Okay.
I minus one.
And
So the
then 1
previous
to I
question
plus 1.
till the
Okay.
length of the text, length of the
Okay.
pattern.
Okay. From that you calculate. Okay. Yeah.
Correct. Can someone help me here? Pooja, are you here?
Yeah.
Can you talk? Like, can you just please read this question once?
Okay.
Visible?
We want to implement Rabin-Karp algorithm with a hash function instead of modulo arithmetic for searching a pattern of length m in a text in base k of length n.
Let's
Suppose we
let once again. Let's understand what this point is meaning. Can someone explain? So we have the same Rabin curve, right? That one also was a Rabin curve, right, Uma? First question also.
Yeah. Yeah.
Okay. So what is the saying? Hash function instead of modulo arithmetic. Okay. What does that mean? Does anyone know?
But hash also has a modulo, no? I thought.
Ah, okay, okay.
Okay. Anyway,
So
let it.
you're coming something like that. Okay. So, so if the number was like 100, and if your hash hash is going to 100 modulo some big number. right,
Yeah,
Uma?
yeah. That's
Okay.
how we
And
do
this will
hash.
give us okay. This will make sure that the number, whatever number we are giving, doesn't
Will
exceed this
have
one.
rules. Yeah.
Okay, okay. I'm understanding something. Go ahead, Pooja. You're also okay with that?
Yes.
Okay. Of
Suppose
modular
we
arithmetic.
have
Go ahead.
suppose we have a hash function hx that can guarantee no more than log mk collisions for all x of length m. Hx runs in big O one time.
One.
What will be the upper bound of running time complexity of searching a pattern P in a text T using the above implementation of Rabin-Karp algorithm using the hash function hx?
Okay. So how do we come up with an answer for this? Oh my god. Okay. So seems like we are using the previous one. And what is the complexity for this? Uh, Using that, they're asking us to do the complexity. Yeah. Okay. So Uma, what is the complexity for this?
I couldn't say such. It looks like M for loop, only one for loop, right? Yeah, it is correct. Oh no, I don't know.
Hey guys, I'm just getting a call. I'll be back in a second. Give me some time.
Hi, Uma.
Hi, Ravina.
So, how much you have prepared for this subject? Are you fully prepared?
No, no, the questions are going to be 9, 10, 11, 9, 8. I haven't even started this week 10 and 11.
I want to ask that are they only from 9, 10, 11, or
No,
how
no.
much
I think
weightage?
mostly I think this will be from last 4 weeks only, no? Then they will ask, but will be very less. That's what my I don't know, but that's how they generally ask, right? Even in we are attending end term, no? That's how the questions are, right? Most of the questions will be from the last 4 weeks, and we have very little from the earlier part, right? So
Hopefully,
we
I
know up to
just
8, no, we have revised, but these four are the crucials. I haven't even started. I have to start.
I'm having a feeling like at least two to three subject I need to repeat and the next sem.
No, no, you will get it.
No, the days are not so good here.
Unfortunately, this is very getting tougher. No, I don't know any this all this algorithm also.
Guys, am I audible?
Yeah, yeah,
Okay, now only I'm audible. Okay, fine. Uh, okay, where we? Okay, we are trying to find out the complexity there, right?
yeah.
Okay.
I thought it is M. Okay, it is pre-processing them because we have one for loop and
Hmm.
that won't count. I think that two second one, but I don't know how it is M into M.
What is this pre-processing? To convert
Convert that
the.
into integers, right?
Okay.
That is what that
So
for loop, first for loop.
okay, okay.
That I
That
got it. But
is it what? Converting the pattern, no? Yeah,
that's
that's
what,
what. See, convert
yeah,
pattern to numbers, right?
it's okay. But how do we get M into N? It will be M plus N, right?
Yeah, let's see. Worst case for the general alphabets is. Or repeat, Uma. What did you say?
I was asking it is only M, no? How it got N into M? Maybe, okay, they are giving for alphabets, okay.
Mm-hmm.
Maybe,
May have same remainder modulo Q as the pattern. So
they were saying for alphabets. I don't know what is the procedure for alphabet. That's why M into M.
once again, general alphabet is. I don't know why are they saying the general alphabet.
No, it's not integers, no. Maybe some other procedure is there. To convert alphabet is not the same, right?
Yeah, that's right.
And something else should be there. That's why.
Okay. I think Uma. So what? I'm not sure. I'm not sure. See, even it's been some time. So what I think is, if you're taking numbers from why modulo is coming here, I'll tell you. Okay, why hash function and modulo is coming here, I'll tell you. So if you're taking numbers from I mean 0 to 9, right? So this is of base 10, right?
Yeah.
Okay. So if you want to check the pattern for one second. So sorry guys, so much background noise. There's a function in my house. Am I audible still?
Yeah,
No
yeah.
more noise.
No.
Yeah. Uma, so if you want to, check for pattern from like you have numbers, okay, 1, 2, 3, 4, 5, 6, 5, 4, 3. So like if it contains all these things are basically each character is a subset of 0 to 9. Okay.
Yeah.
If it is like this, you will do a modulo 10,
Yeah.
right? So if similarly you want to search for a pattern in alphabets, okay, so something like A B C D E, so till Z we can take, okay. So this is going to have 26 characters, and here they are trying to do something like modulo 26.
Okay.
Got it? Yeah. Okay.
Yeah.
Okay. So that's what they are trying to say here. But they have shown us, just a small simple implementation over here for the numbers, and alphabet they will be extending it. Okay. So M here N into M is basically what is N? N is the
Size of text, I think, right?
uh, is that it? N B N Okay, size of text. N is the size of text. and
Okay.
M is the
Center
pattern
pattern.
length.
Yeah.
Okay. Modulo
It's
Q
okay.
as the
We can
pattern.
move ahead, Gokul. Time complexity will take time. It's okay. Just
Time complexity will take time.
yeah.
Nice. Okay. So this is just I told you right that converting alphabet to hash model or something like that. So that's what is coming back here. And try to look at this later. Hmm? Or they would have done this in the live session. Okay. So automaton. Has anyone gone through this automaton already? What is this automaton and why do we need this? Pooja is here.
Yes.
Yeah. The later weeks, it's gonna be a little bit troublesome. Can you tell me? Can someone tell me what is this automaton? Okay. No idea. No guess. And here the answer is three. What state will the following automaton reach on reading the pattern? Going, 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 going. The starting state is one. How did they come up with this graph? Oh my god.
Check the PDF of the lectures.
Slides, right? Come on.
Yeah, yeah, yeah.
Slides or lecture? You want me to
No,
show the
no.
lecture?
Slides.
Just
If you
slides should
can,
be enough.
it will be easy.
Yeah, I'll just duplicate the pdsa and all. It needs every day of study session, mentor session, or everyday group study session. Right? Not mentor session. At least group study session would help every day.
To discuss,
Uh,
we should learn. No, I don't know anything. If somebody knows, it will be good.
yeah, well, that's how we used to study. Like while we were studying, so every day 1.5 hours, 2 hours. Even we even watch the lectures also.
Okay.
String matching using automata. Okay. So let's not talk about the Boyer mode because we still don't have a question there. Let's go directly to automaton.
What will be the first, I think, automaton? Are you taking the first slide?
See, string matching using automata. That's what we are.
Okay. Oh, okay.
So traditional string matching is take a text pattern of length n and m. So for each starting position I in T, compare blah blah blah. Can right to left. Right to left now. What does this mean? Okay, they are coming from the end now.
I think so.
Okay, okay. So shall we explore this point at least first? Or shall we watch the lecture? Shall I just share a screen and play the lecture and we'll be able to understand that? What do you say?
Yeah, okay.
That's what we usually do. Share my tab. Okay.
Two different algorithms beyond the brute force which work on strings. So we saw the Boyer-Moore algorithm, which uses the brute force idea with some heuristics for taking care of mismatches and skips over some letters. And then we saw the Rabin-Karp algorithm, which does a completely different thing. It converts the whole string into a number and then relies on numeric comparisons rather than string comparisons. So let's go back now to string-based comparison. So let's deviate back from that numeric comparison to string-based comparison. So what we said at the beginning was that in a traditional brute force or Boyer-Moore kind of thing, we start with our text, and for every starting position, we look at the segment or the slice, which is the length of our pattern, and try to match it, usually going from right to left. So Boyer Moore tells us that when we are doing this matching, when we find mismatches, we can be clever. So if the position where we find a mismatch does not appear in our pattern, we can skip beyond that position. So we can update I to I plus j plus 1. And if it does appear in my string, then I can pre-compute this last of C and shift it so that the position where it appears in my string aligns with the position in the text. So this could.
Do you guys want to see Boyer Moore also?
No. Just automaton is enough. We can skip this.
Okay.
Allow again to skip over some useless matches. But though this heuristic works very well in practice, as we said, it does not change the worst case from that of the brute force algorithm, which is order n times m, because we could have this trivial pattern where the same letter occurs repeatedly in my text, and the pattern is just a small variation with one b before m minus 1 is. So now we will try to see if we can beat this worst case and get something which is proportional to n. So in the Boyer-Moore algorithm, what we are trying to do is learn from mismatches. So whenever we see a mismatch, we accelerate the search by pushing our index forward. The other approach, which is what we're going to use in the new algorithm, is to remember how much we have matched and see if we can update that intelligently. So can we intelligently reuse partial matches that we have seen so far? So let's look at an example. So supposing we are trying to search for, this is my text, right, on top, and this is my pattern. So I'm searching from the left. So when I reach this AB, and I have not yet found a mismatch in my text, I have implicitly found a prefix of my pattern in the text so far. So that is the letters AB in orange in my pattern. So we have a prefix that we have matched so far, right? And this corresponds to, in general, a suffix of what I have seen in the text, because the position of this text right now it's at the beginning, but it could be in the middle. So if I'm in the middle of the text, then the part that I have matched in my pattern will not be the entire text, it will be the last few letters in the text. So the suffix, right? So the suffix is when I take a word and I take something from here onwards. So this is a suffix, right? And a prefix is from the beginning up to a point. So there is a prefix of the pattern, which is a suffix of the text, right? So the last few letters in my text match the first few letters in my pattern. This is what we generally have as the information that we get when we are proceeding in a block without finding a mismatch, right? So now the question is, what happens when we extend the search? So the good case is that the next letter that I'm looking for in this block matches the next letter in my pattern. So earlier I had AB, and the next letter here is A, right? And this matches the next letter here. So the prefix that I have matched grows from AB to ABA. So this is good. But now what will happen next is that I will find a mismatch, because in my text I see a B, but my pattern requires me to see a C. So if I were doing something like Boyer-Moore or a brute force, at this point I will now shift my entire focus and restart a scan from scratch, right? I will shift to a new block. I might shift to a different position in that text, but I will essentially start scanning my pattern with zero information about any match. Instead, what we can observe is that if we are at this position, right, we still have a match, right? So there is still some part of the text we have seen, so we can believe that we have matched AB, even though we failed in our last attempt to extend that original pattern to C, right? So I will reset this longest match. So now we are in the situation where my text has come up to here. So notice now that I have a suffix of my text which matches a prefix of my pattern. So now if I proceed, I will see that the next letter matches this, the next letter matches this, and I will report success without having.
Okay. Did you guys understand something? Any doubts in this point as of now?
Yeah, got it. Yeah.
Others. Pooja? Anwar? Hey, please feel free to ask.
Yes.
Okay, Pooja silent.
Having to go back, right? So this is the main message
If anyone is having a doubt, please interrupt then and there. Okay, we'll discuss that.
here is that if we can remember somehow, right, how much of the pattern match remains valid, then I can believe that I have actually matched that much. So instead of restarting from here and going forward, which is what I would do, I can already kind of internalize the fact that I have matched 4 characters without scanning them and proceed from the 5th character onwards, right? So this is what we are trying to do. So how do we do this reset? Well, we are going to do it by pre-computing. So just like in the Boyer-Moore algorithm, we learned how to align letters by doing this last computation. So here we are going to see if I find a mismatch, and if my current pattern was so much, then what is the remaining pattern which continues to match after this? Okay, so that is what we have to calculate now. So we will use a graph of a special kind to do this pre-computation. So let's assume that my pattern has length m as usual. So I will have a graph in which I construct m plus 1 nodes, 0, 1 up to m. So let's assume that m is 6. So we are doing it with our example AB, AB, AC, the same example as we had before. So this is length 6. So I will create 7 nodes, 0 to 6. Right? Now what I will do is I will construct edges. So the edge will tell me how much the match has extended. So the interpretation of node I is that I have the sequence I have seen so far matches up to position I. Right? So if I've seen an A, so remember that my pattern is AB, AB, AC. So if I've seen an A starting with the empty string, then I have matched up to position 1. So I go from 0 to 1 in my graph. Right? After I see an A, if I see a B, then I've matched 2 positions, so I go forward. So as long as I do correct matches, I keep going forward. Right? So let's continue and finish a few more edges. So A to B takes me from 0 to 1. B, sorry, from initially an A takes me from 0 to 1. After that, a B takes me from 1 to 2. If I see an A after that, then I match 3 characters and so on. Now, last time we saw in the previous example that you could have a situation that after I see A, B, A, B, A, and then I see a B here where I wanted to see a C. Right? So here what will happen is I do A, B, A, B, A, and now instead of proceeding forwards, I want to be able to compute that I have now seen a prefix of length 4. So I would like to say that if I've seen a prefix of length 5, which matches AB, AB, A, and the next letter is a B and not a C, then I don't give up hope. Right? I recognize that I've still seen AB, AB. So instead of seeing a length of 5, I've now seen a length of 4. So this is what we have to do technically. So we have to go from a position I, so any position in this graph, and if I read a letter A, then I must go to a new position, which tells me how much of a match survives. Right? And this is all within the pattern. Right? So if the position matches, then I just go forward. Right? If the position doesn't match, then I will look for the longest suffix that matches. Right? So basically, I can do it by brute force. I can look at AB, 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 and I can look at my text AB, AB, AC. Right? And I can ask myself at this position, what is the longest prefix that matches? So I know that the longest prefix that matches has to be less than or equal to length 6 because that's the length of my pattern. So I can ask, does a pattern of length 6 match? So I can take 6 as my initial thing, right, and check, and then I will find that it doesn't match. Right? Then I can ask whether a pattern of length 5 matches. So if a length 5 matches, I must start here. Again, it doesn't match because this A is equal to this B. Then I can ask whether a pattern of length 4 matches. So then I will start here. Then I can say, okay, this B matches, this A matches, this B matches, this A matches, and I can say yes. Right? So I can exhaustively for every letter that I add, I can take the pattern which I have right now, look at the last m characters I have seen, right, and go through that and look for shorter and shorter suffixes. So I start with the longest possible suffix m and see if it matches the entire pattern. If it doesn't, then I start with m minus 1 and start from the second last position pattern and so on.
Guys, okay, yeah?
Yeah, got it.
You have got some idea. So what is this question? The starting state is 1. What state will the following automaton reach on reading the pattern? Okay. How do we answer such a question? I just copy the pattern alone so that it will be visible for everyone. Okay, is the pattern visible?
Yeah, but where is the text? How can we compare?
So actually this diagram is for the pattern. Wait. What state will the following automaton reach on reading the pattern? Blah, blah, blah. I'm not sure. Okay, the answer for this question is 3. Let's observe how this is. Okay, Uma.
Yeah,
Hmm? So, let's you read this. Okay, so A to B. So first we have A. That means we are in this question. Then we have B. So since we have B, we come here. Okay. Then again B. So we move forward. So now we have A. So you go to this point. You follow what I'm doing,
Yeah.
right? So we come to this position. So what's next? It is again B, right? You
B,
go front. Okay. Then
A, then, so going back again.
B, and then after A, after B it was A, right?
Yeah.
Okay. Then we have a B again. 2B, right? Basically,
Yeah.
you are not able to follow.
Because there he
Okay.
was comparing with the text. Here I don't know how we are
One.
comparing.
Yeah, I'll come back to that. Okay. So first we have A. I'll take a different color. Okay. We go from here to here, right?
Yeah.
So you're starting here, and we have a A. So since we have a A match, so you move to this position. Got it?
Yeah.
Okay. Now A is done. So from A, then you go to you have a B. So since you have a B, you're moving forward to this position. Okay. Now you are at this position. Okay. So from this point, so if you're having again A, you have to go to 1.
Yeah.
If you that's what. If you have a B, you go forward. If you have a A, you go backward. That's what this diagram shows. So now you have a B, so which means you move forward.
Yeah.
Okay. So then we have A. We come to number 2. Okay, I'll write it here. Okay, then we have B. So which means we are going to 3. Am I right, Uma?
Yeah.
Can you tell further?
For A, we are going back to 2, right?
For A, we are going back to where?
2.
How come 2? Because see, you're at position 3,
Okay.
right? So you have an A here, which means this arrow is making you go to 1.
Yeah.
So you are going to 1. Okay, you got my point? What I'm saying?
Yeah. But
Okay.
why have you
Now
written that the second A is 2 then? That also should go to 1, right? A,
uh,
B, B,
A B B A. Okay. So A is A. You're coming here, right?
A.
B.
Yeah.
You have another B,
Yeah.
right? From this point, if you're getting A, you're going to this position. See, Uma, you are able to see this graph at the top.
Okay.
So if you are in this position, you need to go to wherever you have the direction.
Okay. Now, how you say 1?
How I say 1? Because so B B you mean B B A you are here, right? So again you're having B, then which means this B is 3, right?
Yeah.
Okay. Then after B you are having A. So after for this B you are having A, which means this position. You got my point?
Okay. Okay. Yeah.
Okay. So from here you have a B. What does it do? It's just a loop to itself. See this. Now your pointer is here. Okay.
Okay. So you travel back and then you're looping. Okay.
Correct. You're looping it.
Why
So
do we
one,
go back to that
one.
B? I don't know.
Sorry, Uma.
No, why do we loop? Why can't we reach this B? We
This
don't
is
go.
the autometer graph they have developed and given to us. Don't
Okay.
ask me why, please.
Okay. No, no. I was thinking. Okay, it is traveling back. So okay.
Yeah. Let's try to answer this question here. All right.
Yeah.
We'll explore it. Let's find out, come up with a solution for this. So you don't have a C, which means you still stay there only, right?
Okay. Yeah.
So C again. Now we have A, which means for A you're going to question 2, right,
Okay.
Uma?
Yeah.
Okay. From then next A to B, which means you go to 3.
Okay.
Then you tell me.
4.
Very good. Then so from 4 you're having a C, right?
Yeah.
So what is it? Huh?
I think so. Because
Did you say
moving
something?
forward. No, I'm not getting why it is 5, right?
Are you getting 5 or not? You're not getting why it is 5. Leave why it is 5. So the question is. if you're traveling this graph, where you will be at the end of this traversal? That's the question here.
Okay. Okay, 5.
Hmm? So 5. Okay. So from fifth position, you are having a B. Now where do you end up?
6.
Right? Is it 6? You're having a B. Means you should go in the B direction. From 5, you need to go in the B direction.
It's 3.
Yes. Got the
So
answer?
while going back, you're choosing the nearest alphabet. Can I take it like that, right?
According to the arrow mark.
Yeah.
No, it's according to the arrow mark.
That's what. We're not going to the second B, right? Only first B we're traveling back, right?
Second B, first B.
Sometimes, no, down also there is one arrow, no? From 5 to 1 also there is a B.
Yeah.
From that 5, we are not traveling this third B. So I couldn't get it properly. Okay, I'll watch the lecture. It's okay. Okay, it's fine. It will come. That automata is
Pooja,
difficult.
you want to say something? Pooja, did you follow this?
Only last one.
Only the last one you're not able to understand. Why? I mean, why we are going to 3 and not 1? Is that what your question is?
Yes.
Or, okay, okay. So even I'm not able to answer that. But this is how we used to do it. Uma, can you please check it out later?
Yeah, yeah. I think that lecture we will complete, then we'll at least see whether we can understand.
Somewhat, some idea you're getting over here, right?
Yeah, slightly. Yeah, yeah.
Okay. Please adjust here. And these weeks become more and more. Okay. So here comes the Boyer-Moore algorithm. For which of the following pattern in Boyer-Moore algorithm, the number of shifts of the pattern is maximum. Consider one shift for each time when the pattern shifted to the next index position for matching. So for this, we need to know what is Boyer-Moore algorithm. Pooja, have you watched the lecture?
Not yet.
There are like 12 weeks, right?
No, no,
Last week is just a
no.
summary.
Yeah, yeah. Only the 11th week. 11th week is also very tough, but I'm planning to watch the live session. Bhaskar has explained it theoretically.
Okay, okay.
Lectures I never find good.
Okay, so we need to understand the Boyer-Moore for this.
It is confusing because all are same. I watched the Boyer more, but I forgot. Maybe if you go through the notes, I can get it. I'll try to recollect it.
Okay. I also try to I mean, I also kind of know this, but still, I just wanted to, understand it. Okay. So initialize the last of C for C in pattern. Okay. Hey, this is okay. Nested loop for compare each segment. Okay, I think see this will be easy if you watch the lecture. Like, sir will explain it very fast. Hmm? I'll just share the lecture.
Look at that, we can speed up the brute force algorithm, which scans each slice at a time by checking whether there is a letter in my text which does not appear in my pattern. So the example we gave was this A in Banana Mania, which does not appear in bulk. And if we are scanning from the right, for instance, then we can skip forward from position 0 to position 4 in one step.
Did you understand what just happened?
Yeah, from the last, right?
Correct. So from the last of the pattern.
Yeah.
Okay, if you don't have that element in the pattern at all, just skip the whole array.
That pattern size we can skip, right? Am I
Yes,
correct?
exactly. Yes, yes.
Okay.
Puja,
But
a little bit followed.
here it is 4, no, Gokul. He has skipped only 3, right? From the last. Actually,
So
pattern size is 4, right? If K didn't matches, he's moving backward. You should move 4, right?
correct. So then you will say like there is no
Right.
match.
Okay, okay, fine. Okay.
because we know that that A cannot match anything in the pattern. But this is, of course, a special case. What do we do if we have a mismatch, but that letter does appear in the pattern? Can we do anything intelligent in that case? So let's look at this example. So we have this pattern which is called stick, and we have the text which is haystack width. So if we march along from left to right, eventually we will reach, say, this slice that we are examining against our pattern. And now when we do our right to left scan, the first letter which does not match is I in the text and K in the pattern. Now I does not satisfy our earlier skipping criterion because I does appear in the pattern here. But what we can now argue is that if I want to move this and try for a match, I should try to align these two I's. Right? There's no point in shifting this I by 1 because it's not going to match next time either. I know that I've seen an I, so I need to take the pattern I and move it to that position. Right? So I would like to shift now by 2 positions so that these two I's become aligned. So this is the second case. So we have the first case where the pattern, the letter that I'm mismatching does not appear in the pattern and I can just skip over that entire position. And the second case is when I have this match and I align, right? So we're going to scan this substring next. Now, how are we going to find out where this I is? Well, we can pre-compute this. We are not going to go and look at our pattern each time. What we can say is that in the beginning, we go through our pattern once, and for every letter that appears in our pattern, we can compute the last occurrence of that letter inside that pattern. So we will use last as a dictionary, which takes a character and it tells us the position of the last occurrence of that character in the pattern. And of course, if the letter does not appear in our pattern at all, then it will not be a key in the dictionary. So we will be able to check whether the mismatch occurs in the pattern or not by checking the keys of the dictionary. And if it does occur in the pattern, then we can find out where it occurs in the pattern by looking up this last information. So in general, what we see is that we are at some j, right? So this is our position j, and then the difference between j and the last of c. And of course, if the special case where the pattern does not have that character, then we can shift directly to j plus 1. So if we are at position j, right, so this is my last of c. So if this does not occur, so supposing this had been some other letter like z, then I would just shift the entire thing after this to j plus 1. So this was the earlier case that we saw. So before we formalize this as an algorithm, let us do an example, a more detailed example. And this is from the original paper by Boyer and Moore, where they introduced these two skipping rules. So here the text is which finally halts, full stop. There are two spaces here. So notice that the text has spaces and so does the pattern. Right? So the which finally halts, full stop, two spaces at that point, and the text actually that we are searching for, the pattern is at that. So as before, we start at the beginning. So we are just doing this brute force scan with this optimization. So we try to scan this string starting from the beginning. So since at space that has 7 letters, we look at the first 7 letters of our text. So we start from right to left. So we will get a mismatch here, right? But what do we know about this mismatch? Well, this mismatch involves a letter F, which is not there in my pattern. So the rule says that if it is not there in my pattern, I must shift this entire pattern to start from here. So I must shift it by, in this case, to beyond the F. So I must shift it to pattern position 7. So I shift the pattern, and now I'm scanning from the I in finally onwards. So now again I have a mismatch at the rightmost position, but this rightmost position is a space, and the space occurs here. So in such a situation, I must shift by this much, right? The difference between the two positions. So I must shift by 4 because the difference between.
Pooja, you're following this, right? Oma, Pooja.
Yeah, yeah.
between this space and this space, there are 4. If I add 4 to this, I come to this point, right? So I must align this thing by shifting by 4. So I shift it by 4, and now I align ly space HALT with at that, right? So this is my next thing. So here, if I go from the right, then this becomes my first mismatch. So this mismatch again involves a letter L, which is not there in my pattern at that. So since it is not there in my pattern, I must go past it and start from here onwards, right? So I shift by 6, and my next search starts at the TS of halts. So now what do we see? This matches, but this is my first mismatch. Again, it's a space, and a space occurs here, and they are 2 apart, right? So I have a space in the pattern which is 2 before the space in my text. Now if I go again, there is a space which is my first mismatch, right? And this time I must shift by 3 because it is 1, 2, 3. So I move a, a complete match between at and that. So starting at 22, I have a match. So I would have recorded this in my list of positions where there is a match. And now if I have a match, then because of the nature of the pattern, supposing for instance, we saw that if you had all A's in my text and you had the pattern like this. So if I find a match here, I should just move ahead and look for the next match. So I must just go one step forward if I have a match. I can't skip. I cannot assume that the pattern does not overlap with itself. So I will now move by 1, right? So if I find a match, I will move by 1 to the next position, right? And it must, right? But this n is less. The thing to note is that there are 35 positions actually if you count in the string. And notice that we have only scanned about 8 of them, right? Or 9 of them, 8 I think. So in practice, though, the brute force thing starts for every I. With this skipping heuristic, you can actually skip over a large fraction of the I. In this case, we are seeing roughly about 1/4 of them. From this and 7, you can say that there should have been about 28 starting positions, and then out of 28 starting positions, I'm seeing only 8. Right? So it's between 3.5 to 4 as a factor of reduction. A mismatch, I stop. So it's not that every scan also takes 7 steps. So this is the advantage of doing this heuristic. So you get this kind of skip over speed up. So you don't even see the whole text. Okay, so that's a very important observation, that you can actually go through this text without seeing all the letters and still be sure that you have found all the occurrences of the pattern. So let's look at an implementation of this. So we get the last for several, we have text. I have to straightforward because the
So I think that was Boyer-Moore. We
Yeah,
got the logic.
yeah, it's easy only. Yeah.
Mm-hmm. Right. So they are asking, consider one shift for each time when the pattern shifted to a new index position for matching. Okay, okay. So how do we answer this question? Okay. So I think,
We have to check
Uma,
the
so I,
last, right? Yeah.
correct. So are all the text the same? I think so, right?
Mm.
All the text are same.
Oh, only
Okay.
the pattern is different. Okay.
Yeah, only the pattern is different. Hmm? So what
Okay.
we'll do is,
Okay.
yeah. So I have the text. So and we have the pattern. Okay. So I'm pasting it. Just someone keep track of. Pujar is still here. Balaji, hi
Yes.
Balaji.
Yes.
Hi.
Yeah, yeah, yeah.
Hi. Hi.
So yeah, yeah. So I think Pooja will take. You can do this, or like, you try to do it for the next one. Pooja, you keep track of it. Okay. How many shifts we are doing here? Okay. Uma, you tell when to shift. Got it?
Okay.
Okay. So what do we do? So we see this position, right?
Yeah,
The
shift.
last. So we don't have a C in this ABD. So we
So
shift
shift.
the whole thing.
Yeah.
1, 2. Means it goes like this.
No, after C, right? Yeah. Correct. Yeah.
Yeah. So we have done one shift. Pooja, you keep track of it. Yeah, okay. So fine. Okay, Uma, again. So we have an
New
A
shift.
and
Yeah.
What do you say? You go
No,
ahead.
no match, but we have a match in the pattern.
Correct. So
We
I
move,
need to
yeah,
like this.
by 2.
yeah.
By
Yes, very good. Yeah, Balaji. Okay.
Now it's
Uma,
complete match.
Yeah.
now we have a match.
So we have to move only one string.
One string. Correct. So far, how many times we have moved?
3.
All right. So
Not
let me just.
mismatch, but we are
3 plus 2 plus 1. 4. 4 positions, 3 shifts.
Okay. Okay. It is, so we were here and we are moving it one question here. One question. Okay. Go ahead.
yeah. So no match, but there is a string match in pattern. So we move 2 positions, right? They're
Yeah.
matching
2
A to
positions.
A. So now the shift is 4, I think, right?
Hmm.
4
So
shifts.
no match, but we have string, but it's already in the same position. So
So we don't have a C, right? So we can directly go ahead.
Yeah.
yeah.
By 3. Shift by 3.
Correct. And we have a B. We shift by one position, right?
1 shift by 1. Yes.
Very good. Yeah. And we don't have C, so we
C.
can.
So that's it.
It's completely done. So how many?
Okay,
How many did we
completely
do?
7 or 6.
I didn't keep track of it. Pooja, did you keep track of it?
5.
No, more than
No,
5.
it was more than 5.
6 or 7, I think.
6.
Okay. Instead of explaining this, now that everyone knows how it is doing, we just say directly take the count. Okay.
Yeah.
So this
1,
is 1.
2,
This is 2. Right. Now we have
yeah,
a match. So it is 3. Right. We have three movements.
Yes, 3.
4,
Right. Now this is
4.
4, and we
completely
don't
change.
have anything.
5,
So this is 5.
5.
Okay. We have
6,
6.
yeah.
6.
Then
Wait. Still we need to move, right?
yeah, 7.
1 is there. 6 or 7. Be it 6 or 7. Okay. Let's say it's 7. Let's consider it as 7.
Yeah.
Okay.
7. Yes. Yes.
So okay, for the first option it is 7. Someone please at least keep track of that.
Yeah.
Now we'll go for BCA. Okay. Yeah. So 1, right? C and C match. Okay. Now this is 2. Okay, one position. C. Are you guys following this?
Yeah.
Okay. A. What should I do now? So three position I have moved. So A is matched and A we don't have. So how much should I move?
Completely we can move, right? 1 is
Why?
match. Okay.
Shift by
Why
3.
complete? Why shift by 3? That's my question.
A is not matching. A is matching. But next A, there is no match on the other side.
Okay,
And
so that
C
means we
also
need to
is
move
not
it by 2
matching.
positions. Move it by 2 positions or how many positions? Why 3 positions? I think 2 positions here. We have one
Okay.
match here, right?
Yeah.
Okay, now, yeah, no match, so we
So
can
totally
complete.
4 positions were there, no match. Okay. So how much did we move? 5, yeah?
No, only
5 or
one.
6?
No, the C is matching, we can move the C to C.
No, totally how many shifts we have done?
4.
4, huh? Pooja? Okay. Now if I do a movement, that's a 5. Am I right, Pooja?
Yes.
Yeah. So this is 5. And we have match. Now I'm moving it. So now this became, 6, right? A, and we don't have that. So we need to move it by 2 positions. Right, Balaji?
Yes.
Right? So I lost the count again. Pooja, help me here.
This exactly 2 position I could not be able to understand how it is coming to.
Yeah.
That is A and A is matching. A and C are not matching. So why to shift by 2? Why not by 3? That's what I found.
Okay. So even Umar is also having the same doubt. We'll go ahead.
Sir didn't bring that example, no? We didn't notice, or maybe we missed that part. I think.
Sorry, Umar.
No, we missed that part. When it is matching, what is happening, we missed it, right? In the
Correct. Okay. Is it possible to check it over, take it over here, find it out here with the code?
No, it's okay. Only that point. No, let us find it later. It's fine, I think.
No, but still that's important, no?
Yeah. Maybe can you find it in slides?
Yeah, I'll check it. I still have it here
Patterns may
only.
still depend. Two,
Only audio
my
is not there.
class list, because I'm doing
Not the
this right
audio.
click, that four can actually, right? And if I find a match, I will
So
move
here
by
we
one.
have a match. Okay.
This
Let's
mismatch,
start from
well,
here.
this so the shifted 7 onwards. So and the space shift because right, ly space HALT with at that, right? So this is my next thing.
So
So here, if I go
okay,
from
wait a second. So here T and T matches and we don't have L. So so shall I play it from here? Play the audio from this at this point?
Yeah.
the right, then this becomes my first mismatch. So here, if I go from the right, then this becomes my first mismatch. So this mismatch again involves a letter L, which is not there in my pattern at that. So since it is not there in my pattern, I must go past it and start from here onwards. Right? So I shift by 6, and my next search starts at the.
So okay.
Okay. We passed it next of that mismatch, I think. So it's fine. Yeah.
We should
So
shift
like,
entirely by up to that point. I think we should.
I think that's what we also did here,
shift
right?
entirely. Yeah.
Yeah, that's what we did here, right? Up to that point, and we moved it, right? When we had A, right? So
We have to
it
move
was
after C, right? There was a mismatch for us. It's C. So we have to move after C, I think.
so see, Uma, at this point, the question is, so A and A is matched. So you don't have A. So how do I do it? So I take this
That is
beyond
after
A.
that the second. Up to that second A, we should see. That second A should be starting the first one.
Correct. That's what I had done, right? That's how we are doing, right?
Yeah. Okay.
Great. Okay. So wait. Oh my God. Sorry. I think sharing a wrong screen. Sorry, guys. Okay. So here we were. Uma?
Yeah.
So at this point, we have, okay, at this point, right? So A and A is matched. Now A is not there in the pattern anymore. So we move it beyond A,
Yeah.
right? We do it like this. Okay, great. I think now the point here is you need to keep track of how many matches you have.
Yeah. I think we can take the second one. That will be if it goes beyond 7, just we'll consider it. Yeah. It's okay. Now we got it.
Yeah, this is going beyond 7. We saw that.
Okay.
Are you still want to do it? Guys, are you okay with this?
Yeah.
Probably we are looking at, in-term question papers. If such a thing comes, we'll do it again.
Yeah.
Yeah, but can we say it is a maximum or minimum? When we say by finding out the pattern exactly, we cannot say. To calculate for each pattern and text, we have to match and calculate. Is there any other shortcut or trick or something like that?
No, even this is the easier one only. It won't take too much time. See, in order to explain only, it's taking too much time. And I'm explaining it over, the problem is if I come out of this, I won't be able to mark it anymore. So that's why. If I put one, okay, one. This is interesting. So if I see a match, I'll put a thing, ash. Is that fine? For every shift, I'll put an ash.
Yeah.
Okay. So we don't have a, okay, we have a match. So one. Am I right?
Yeah.
Okay, so we have matched one. We are moving in one position. Okay. What is next?
Again C, so we can
So
move one
see,
step.
again one more question we need to match it. Move, right?
Yeah.
Okay. I moved it once.
Now A is there.
Mm-hmm. So
C is
this
also
alone is not matching. So one more question I need to move.
yeah. B.
Okay, fine. So A and A is there. So here this is not matching. So we go beyond A, right? So
Yeah.
I do two spaces and Ash. What
So
brother?
one doubt here, Gokul. That
Yeah.
C, we will not move it reverse at any cost, right?
No, we are not moving.
Only moving forward, right?
Correct. Yes.
Okay, because that at that point the C was there, but we are not going back.
Yeah.
Okay, yeah.
If you don't find it A again, so you just move beyond that A,
Okay.
right? So now we don't have a D.
Move
Balaji,
completely.
now we are able to keep, able to keep track of how many movements we have done.
Yes, yes.
Hmm? So
Actually,
C. Hmm.
if
What?
it matches two, if it is matching two, then we need to
Hmm?
shift by only one. So that means
Correct.
maximum number will take place when there is a two matches and one mismatch or something like that. Maybe.
Maybe, but it varies according to this points here. I mean, to
Text.
the text or pattern, you can say. Right. Let's just finalize this alone and move ahead. Hmm? So here
One
C and C is matching one position. Right. One position means a single hash. Okay. So again, Uma, it's a complete match.
complete
Right.
match, so
One
we have to move only by one. Yeah.
correct. One moment. So what else is there?
Complete match.
No, bro.
No,
Now it's not complete,
now
right?
One
it's not
position.
matching. Only one position, but still.
It's
A is
two
matching, but
movements.
Two. You have to shift by two.
Two positions. Yeah,
You
two
have to
shifts.
shift by two. Yeah.
Correct. Good. Okay.
Okay.
So we have C. One position we have
We
to
have
move, right?
to only
Yeah.
one shift. We have to.
One shift. Hmm. Right. Again, one more shift. Let's say that it's one more shift, and we have gone beyond this. So that's all. So how much do you have in total? 4, 5, 6, 7,
9, 10.
8, 9, 10. Yeah, we have like 10. So you have to do something like that.
Yeah.
Okay.
Yeah.
This question, like if you're practicing it, you won't take more than 2 minutes to solve this question.
Yeah.
Okay.
Time
Great. Sorry, Uma.
No, no. Next question looks like time complexity.
Yeah, it's time complexity again.
We will just check from the okay, go.
Okay. What did you say? Repeat.
No, we can refer the GitHub notes because time complexity we don't know, right? We have to go through it.
Yeah, we don't know. We don't even know what is KMP,
Yeah.
right? So for that we need to take a different session, I think. Okay, let's try to understand this. Then we'll come back. So one of which of the following searching pattern is the worst case for the Boyer mode? Can someone tell what would be the worst case for this?
The second one, A, B, 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 B. No.
No, no, no. Sir used to say this point. This is the worst case.
Oh,
Balaji, did you note that point, Pooja?
Yeah.
Yeah.
Yeah. Okay.
Maybe that
So
one also.
sorry, Pooja.
Last one
Maybe
also.
last one. No, last one is not. Why it is not?
Last
It's
one
because
will skip by three. I think this
I
will
think
skip by
it's the
only
best
one.
case, guys. I think isn't okay. It's not the best case. So it will skip by
Yeah.
one now.
Yeah. Got it.
So I mean, three steps it will keep on. I mean, four steps it will keep on skipping. I think.
yeah. That last one is the best case, I think.
Right. And the pattern is what was the pattern?
It's
B
6 by 4.
A yeah.
No, no. A, B,
No,
B, B.
A B B B A B B B. Okay, Pooja. So now see, B
Skip
A
by
this is not
3.
matching. So we move it three positions.
Yeah, then 3.
Sorry, three positions, right? Yeah. So somewhat like this. Oh wait a minute. What is this? How should I do?
Yeah, that
Here.
3.
So I need to match this
Let's
A with
prepare.
that A.
Yeah, it's a 3 position we'll move. Yeah.
It skips by three. It jumps
Correct.
by three.
Yeah.
Yes, yes. Hmm. So
Here,
now again,
yeah.
1, 2, 3, 4, and Ash. Right? Again, we do the same.
Yeah,
Pooja
that's
got this? Okay. So if it was, completely B,
Yes.
okay. Now see what you have to do. So B is matching, B, 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 everything is matching. We just need to shift it to one position, right? Again, one position, one, 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 one.
okay. So the
Hmm.
suffix we should
Jumping
change.
is only one.
Correct.
So if the suffix repeats, then that is the worst case. Can we take like that, right?
Yeah. And see, you also have BBB, and here also BBB.
Yeah. Yeah.
So see, every letter from the last you are comparing it again.
Oh,
You
okay.
have to redo the comparison again and again and again.
Okay. Yeah.
Okay, great. Um, we'll continue. Like whatever we have done. So if we have similar questions, we'll try to answer the same for practice. I mean, graded assignment. Okay.
Okay.
Then maybe tomorrow we'll try to have a session and do the KMP algorithm. All right.
Yeah. Yeah.
Okay. So brute force algorithm, worst case behavior. What is the brute force algorithm? Does anyone know?
Yeah. Brute force is a scanning one by one kind of thing, right? That normally, like what we do without any algorithm, just go by
Hmm.
your. That's what brute force, right?
So, okay.
One step at a time.
Yeah.
One step at a time.
Yeah, one step at a time. Huh?
Starting.
All starting from the end again the same. Right? We don't skip it. I think. Okay.
Yeah.
So let's say we take this example, Uma. Okay.
Okay.
And the pattern is triple AB. Can you help me with the brute force? What do we do?
Yeah. If you don't match, we think just move only one set ahead.
Okay, it's not matching, so we move one position. Fine.
Yeah. Not matching one
Not
position.
match one position. So it is matching. A is matching. This is also matching. Now this is not matching. Again one position. Again we come back BV and if B is not here in this whole thing. So ideally in Boyer-Moore what we used to do is we used to skip like this, right?
Yeah.
Hmm?
And brute force is not skipping anything, I think.
Yeah, we don't do this much. We just go one extra movement.
Yeah.
I think, right?
Yeah.
If there is a mismatch or something like that. Okay. Pooja, you follow a little bit?
Yeah, yeah. So
Maybe if you don't understand also, you can try to see the lecture. This is the easy one. But how do we tell this is the what would be the worst case for this? And how do we say this?
Number of the comparisons is very high each time, I think.
Okay. So and how is this answer? Why
That
is
is,
there
it will
more
match. It is
comparison?
still it will be match on the leftmost thing only. So that only it can move only one. Number of comparisons also will be more. I think. So,
Okay. Does it mean that one second, guys? Brute force. Hey, look at this. It's left to right only. I think I was wrong. Uma,
Oh,
yeah, see, it's again left to right only. So that's
no,
why, see,
left.
since it's left to right only, the A and A match compares, A and A compares, A and A compares, then A and B you are comparing, it's not matching. So you move by one position. Again, A and A compare, A and A compare, A and A compare, and then A and B
We're
compare.
talking about the pointer, right? You're coming back left and then you're moving. That is why maybe that's what.
Correct, correct. Yeah. So it's left to right.
Because the loop
Got the
is
point?
coming back. The pointer is
Yes.
coming back and again and again. Oh, that's why
Yes,
maybe.
yes.
So for the brute
Okay.
force, okay, that's the called brute force. Okay.
Mm-hmm. Pooja was also fine?
yes.
Okay, great. So now we came with the worst case algorithm for the brute forces. The other just opposite of the Boyer-Moore, I think. Fine.
Boyer-Moore, I think it is to match from right to left, right to left. This is from left to right.
That's
Most of
right. Yeah, you're right. Great.
So we want to search a pattern in the text using Boyer-Moore skipping heuristics. For which of the following patterns the dictionary will be the biggest in size?
The last dictionary, right?
How last? Yeah, you're talking. Yes, the dictionary name is last. You're
Oh,
right. So how come it is hypothetical? Why hypothetical? Nice. Okay, let's understand this. Mm-hmm. Okay, wait. I'll show this. I'll show this. I think I can answer this.
I think this is hypothetical. No letter is repeating.
yeah, I also got that. Yeah.
What did you say?
So because of the
There is no repeating
hypothetic,
letter.
no letter is repeating in the pattern.
So
So
we
when you
can't
want to
name
make a
match the,
dictionary,
yeah,
it
So
will
if I
be
have
one
a
one one or something.
if I
yeah.
have
So
a
if it
ABCD,
is
if
a,
I have ABCD,
then
so
it will be four.
is it somewhat like number of unique characters?
Yes, number of unique characters, correct.
So Uma,
I also think so, but I'm thinking about the matching algorithm.
It's
let's show
asking
it.
about the dictionary, no?
They are asking about the dictionary only, right?
Yeah.
Wait, don't worry. We'll go back there.
Bigger in size.
Oh
No,
my
we
God,
can
what a
check the letters, Gokul. We can find out the count of the numbers, right? So,
yeah. I just wanted to confirm that.
yeah. Here it is 1, 2, 3, 4, 5.
Number of unique characters. So what I shall do is I'll put this and I'll print last. Last of P. Are we using it? Okay, here only we have last of Z. That's what print last. Okay. So for bookkeeper, so, so shall I put length of last? It is 3. Why just 3? BOKEPR. We have like 6 more than that. Why only 3? Or should I print this at the end?
I think the last position is for only
Bookkeeper,
the repeating letters, then only the count will match. See, O, K, K, and
book,
E.
BOKEPR. That means only.
So it's counting only for O, K, K, and E, right? Oh, no.
The A, B, C. Oh, okay. So they are taking it for this one. So okay. I didn't read the question properly, I think. So these are all the patterns here. So so I think I should have given it on the right hand side. I should have given it as in this point at this question. Now we'll get that.
Delete that ABC also.
Yeah. Okay. But now we'll get it as 6. You're right, Oma. BOKEPR. That is 6. Okay,
Okay,
you got the logic, right?
okay, so we are scanning all the letters, right?
Yeah, we are just checking the number of unique letters,
Okay.
right? If you want to see, I'll just give this also. So first one was 6. Second one is 7. Okay. And hypothetic, right? This is the answer. So second one was 7. This is third one, which is 8. Uma, followed.
Yeah.
So far that was the longest one. Automate data. You want? I'll give that also. Yeah. See, this is 6. So hypothetic was the longest.
Okay. Unique letters,
Great.
yeah.
Yes. Oh yeah, we saw this Rabin Corp also. We'll try to answer the true or false, but don't worry, Okay. Fine. Which of the following is true? Seems like the first one is wrong, but let's see. We'll read this. Uma, read this. Balaji, you take this. Balaji, take this.
Yeah,
Okay, go
the
ahead.
hash value of the substring of the text matches that of the pattern, then we can guarantee that pattern has been found in the text. That though hash value matches, we have to check now for the hash value will match. But then if the hash value matches, then once again we have to check the individual letters for the individual for the string matching to complete.
Mm-hmm. Okay.
Because a hash value maybe of some mod of 10 or 11 or something, it may get repeated for a particular pattern. That is for initial check. And once
Mm-hmm.
that hash value patterns, then we have to go deeper and check each and every character
Like every
so that the
character.
pattern matches. That
Okay.
is the thing.
Mm-hmm.
So that means that the second will this only second option B is only correct, I think. If hash
Okay.
value of the substring of the attachers matter the pattern, then we have to match the actual substring to guarantee that pattern has been found. I think that is correct.
Mm-hmm.
Then
But
second,
this
third,
hash value. So this is where we were also, we're trying to understand this. What is this hash value? Can you
this
repeat this?
is
How it works?
this hash value. We say when the number when the numbers are large and when the storage is somewhat less, the storage number will be identified by the index or any convenient, say 5 or 6 or 10. Like modulo 11 means up to 10 mod 10 values. So
Okay,
if you are given any number, then we can only see that modulo value, and then in that one we can insert that one.
bro.
That
So one second. This is the option, right? Okay. This is the option you're talking about, right? Which is true, right? So this is the
yes.
okay. So let's say that ACB is the pattern that I'm trying to search.
Then
Okay.
we have to give
Huh.
A means we can say 1, B means 2, C means 3. Suppose if we are given some numerical value to each
Mm-hmm.
thing,
Each
then
character.
ACB
So,
will each character. Then
mm-hmm.
ACB will come to 3 plus
1,
2
2,
plus
3,
1.
1, 2, 3.
3 plus total value of the ABC will be 3 plus 2 plus 1, 6. So
ABC.
now,
So you're coming like this.
so, yes.
Okay.
So no, pattern ka numerical value is 6 first.
Okay, I understand. Pattern for numerical value is 6.
Is 6.
Okay. Okay.
Okay.
Now, if we take
Now
this
we will go
thing,
for ABC. So now
okay,
ABC we will check total value
this,
ABC. Suppose if it is
correct.
6, then
Yeah.
hash value matches first step.
Okay.
Then even then
Okay.
hash value matches. Then we have to go for individually A, B, C. It can
Hmm.
be C, A, B also. So
Correct.
something like that. So
Hmm.
then we have to match a individual character whether that exact string
Hmm.
matches with that
Yeah.
pattern.
So something like AB also can be something, right? Equal, right? AB also will be equal to 6, right?
We have to go
Am
for
I wrong?
individual.
Yeah. Am I wrong? AB is also 6, right? Which is equivalent
But
to the weight of the pattern.
But the number of string you
no,
have taken
but
4,
number
no?
should be 3 only, no?
Yeah.
It should
Yeah.
Yeah.
Okay. That is
it should
also a
not be 4.
concern. Okay. Okay. Okay.
It should
I'm
not be
trying to
4,
understand.
no?
I'm trying to understand.
Yeah, but ABC was like correct because the match is
Correct.
different, but the number is same. So this is the best option.
Okay. Okay.
Actually, the first option is wrong, right? Second option is correct.
Correct. Okay. Pooja, you okay with this?
Yes.
All right. Fine. So Rabin-Cobb algorithm, brute force pattern searching, has same worst case time complexity, which is true, right? Ideally we saw that. No, wait. This is Rabin-Cobb. How? guys?
Though, yes, in the worst case, both may be the same also. In fact, Robin
Mhm.
will be one more comparison we have to do.
Okay. Fine. Okay, fine. So we'll go further. Huh? Guys? So
Yeah.
we have the Boyer Moore. Okay. So this is Boyer Moore. And they are saying that line 17 and line 20 marked as function below. Choose the correct option that can replace line 17 and here. So if the character is in the pattern, what are we supposed to fill in here? Does someone want to say something?
And I said, this kind of detail is really,
Sorry?
no, it's getting tougher and tougher. I said, though we know the algorithm, the notations.
Mm-hmm. Shall we do these things tomorrow, Uma? Remaining?
Yeah. Okay.
It's 9. I'm getting a call.
Okay.
Gotta go. We'll do this tomorrow. We'll complete this tomorrow, okay? KMP
Okay.
and stuff will complete.
Okay.
Okay,
Thank you.
Balaji, thanks
At
for
what time?
coming. Yeah.
Yes. Yeah. Okay.
7 o'clock,
What is
bro.
7
7
o'clock?